Good morning, everybody. This video is going to talk about compound inequalities. So right off the bat, what are they? Compound inequalities are two or more inequalities combined into one. They usually represent situations containing two constraints, like a minimum and a maximum. For example, you want your score on your test to be between 85 and 100. You give me a minimum 85 that you want to be greater than. You give me a maximum of 100 that you'd like to be less than. That would be an example of a compound inequality in our real world. So let's talk about how we would graph them. Okay, we have -3 listed here as our first constraint. We want x to be greater than -3, and equal to. So I'm going to have a solid circle. I'm going to shade it to the right because I want x to be greater than that. Okay, so there's the first part. Second part, we want x to be less than 2. Okay, so 1, 0, 1, 2. Here's 2, right? We want to have an open circle and we want it to be less than, right? So it's going to go to the left. Well, for both of those things to be true, we can really only consider this middle area, right? This portion right here is the only thing that will work for that x, numbers that are greater than -3 and less than 2. So instead of writing it with all of that work, we are instead just going to put -3 to 2. I lost track of my circles, but again, you'll get the point. And we're going to shade in between, okay? Simple as that. So let's look at number 2 without doing it the long way. We're going to put our two numbers down. We've got 3 and we've got 6. We want x to be in between those, right? We need to look at the signs to see what kind of circles we need. X is supposed to just be greater than, not equal to, on 3. So I'm going to have an open circle. And then x is supposed to be less than or equal to 6. Okay, so closed circle, shade in between. Now, one thing I want to point out here is that if I was to list all of the numbers that are in that set, can I use 3? Well, no. So I'd have to start at like 3.1, right? Or even 3.01 or 3.001. Obviously, there's an infinite number of numbers in between here. But I would keep going all the way until I got to 6. 6 is included. So 6 is included, 3 is not included, right? You can have both in a compound inequality. But again, there's an infinite number of numbers between those two because you can get down to the nitty-gritty decimals. Okay? So now let's talk about writing it if they've given you a graph. So we check and we count the numbers. This is -1, -2, -3, -4, 1, 2, 3. Okay, so there's our two numbers. Always start least to greatest. So the first number I see on the far left is my least number, which would be -4. Okay, I'm going to go and just put the x in the middle. I'll deal with the signs later and go ahead and put the 3 on the end. That's the easiest way to start these. In fact, I'm going to go ahead and do it on the next one as well. Looking down here on the next one, this is -1. Over here, this is 1, 2, 3, 4.5. I'm going to go ahead and write these down. -1, let's do an m just for fun, and 4.5. Okay, I'll fill in the signs now. So looking back at number 3, the top one, I'm going to first look to see, is it open or closed? Okay, and on 4, I've got an open circle. So that means that I do not want the line underneath it. It's not less than or equal to. So I'm just going to have greater, right? Because it's going to the right, greater. 3, also an open circle, okay, but it's less than, going this way. So it's also just going to be a less than symbol. So you'll see the x is sandwiched in between. One thing that's important, if you write them from least to greatest, your alligator mouths are always going to open this direction, okay? It's just a matter of where your numbers are that determines the meaning of the inequality. But if you write it from least to greatest, your alligator mouths are always going to open to the right. Okay, so the bottom one, same deal. This one, open circle, so I'm just going to have less than. Right side, this is a closed circle finally, so I'm going to have less than or equal to. Alrighty? Now, what's also important here is how to solve them, okay? It's actually super easy. It is not any different than solving a normal inequality, okay? I'm going to draw lines down my inequality symbols just like I do with equal signs. Here's my variable. I want to get it by itself, so I'm going to subtract 3 from both sides. And by both, I actually mean all 3 this time. So -5 minus 3 would be -8. All that's left on the inside is 2x. And then on the right side, I've got 6. Okay, next step, divide by 2. Okay, 2's cancel. All I've got is x. I've got -4 on the left. And I've got 3 on the right. Although I think I did that wrong. If I look back up here, it's just a less than symbol, so I should not have that line underneath. My bad. There we go. Okay, so there's my final inequality. -4 is less than or equal to x is less than 3. So if I were to graph it down here, I'd slap -4 on there, closed circle, I'd slap 3 on there, open circle, I'd shade in between. Simple as that. Okay, let's do the same thing on the right side. Here's my x, right? I've got 3 pieces I'm going to work with. I'm going to multiply everything by 4. I've got this bodyguard here. Okay, so multiply all 3 parts by 4. It's hard to get a 4 written in here, but you get the point. 4 cancels. On left, I've got 16 is less than or equal to 3x minus 2 is less than or equal to 28. Now I just keep going backwards. Plus 2 on all pieces. So 18 is less than or equal to 3x is less than or equal to 30. Divide by 3, divide by 3. 6 is less than or equal to x is less than or equal to 10. We graph 6, 10, close circles, shade in between. Simple as that. Okay, let me know if you have any questions.